So today we're primarily using this formula here to find terms, or to find the rate, or to find the means, or anything like that. Just like in an arithmetic series, AN is the nth term. So if we're finding the sixth term, N is 6 in both places in that formula. Just like in the arithmetic, all right? A geometric series or sequence is one in which instead of adding something each time to get the next number, what do we do? Multiply. We multiply something each time. And R is the rate that we multiply, okay? So that's the R. A1 is still the first term. And AN is still the nth term. And then SN is still the sum of the terms, okay? So those are the three things. And it's geometric. If something grows geometrically, something grows arithmetically. Let's say I have money that I'm putting in the bank, and every week I get a $4 allowance from my parents, and I put that in the bank. That's an arithmetic addition. You're just adding $4 to your bank account every week. Does that grow very fast? No. But if I'm multiplying by 4 every week, that would be pretty awesome if your parents would do that for you, okay? So they give you $1 the first week, and then $4 the next, and so on and so forth. 16 the next, 64 the next, and it gets very big very quickly. So geometric is going to grow quickly. Arithmetic is more linear, and geometric is more like a rocket ship just blowing up and going straight up. When humans are being formed in the womb, their cells are splitting geometrically, like every one cell turns into 2, 2 turn into 4. And in 9 months, you get billions and billions and billions of cells that make up a baby. So think about that as...
Just like bacteria.
Yeah, bacteria is another thing that grows very quickly, okay? So if I want to find the next 4 terms of this series, we know the first one is 5. We know R is 3, so what am I doing with the 3 each time? Multiplying. So it's going to be 15 times 3 is 45, times 3 is 135, and one more times 3 is 405. See if that's right. They gave you the first one. If they ask you for the next 4, you're just going to multiply 4 times until you get that one. Those are easy. If they want you to find the nth term, let's say they say A1 is 2 and R is 1/2, and they want you to find the 6th term. So instead of saying find the 6th term, they'll just say n equals 6, okay? And you're going to use that formula up there where you put the 2, then you put the R, 1/2, and then you have n minus 1, so it's to the 5th. So that's 2 times 1 over 32, which is 1/16, I believe. Somebody put that in the calculator. So if we have 6, comma, blank, comma, blank, comma, 3/4, and we have that, we have to find R in order to find those spots. So I know here that to get from here to here, I have to multiply by R, and here to here, I multiply by R, and here to here, I multiply by R. So 6 times R cubed equals 3/4. Divide both sides by 6, and that's 9, what is that? 3/4 divided by 6. 1/8. And so to leave the R alone, I cube root both sides, and I get R equals 1/2. So when I multiply 6 by 1/2, I get 3. And when I multiply 3 by 1/2, I get 3/2. And when I multiply 3/2 by 1/2, I get 3/4. So I am correct. I filled in the blanks. Each foot of water screens out 60% of the light above. What percent of the light remains after passing through 5 feet of water? And here you just have to, I always start off with 100% of light, right? It's at the top of the water. And then you're just going to go down 1 foot, 2 feet, 3 feet, 4 feet, and 5 feet, each of which is 60% of the one above it. When you have 60% of something, what do you multiply? 0.6. So you should be able to do that one and find what amount of light will be left 5 feet below. If you've ever lost something in a lake, it doesn't take long when you go down to find it before you can't see anything. It's because the light coming through the water gets less and less as you get deeper and deeper, okay?